recording. And I think today we will, hold on, let me first need to get to the screen. No, not this one, should be here, this one. And then over here. So today, what we are going to do is we will continue our discussion about the case study. And this is the next case study. It's about the baby names analysis, okay, between 1880 to 2010, okay. It's there are quite a large number of records. And it's also involve multiple files. So how do we get them combined into some single record for us to do the analysis? Okay, so we read the CSV. This is just one of the single files, is it? And here it shows just 1880s, is it? And then here it's also try with that single file, do the group by, okay, and then group by female or male, that boy and girls numbers. So that's just to give us some glimpse of the information. And what next part you will see, because in the real world, this is also going to be going to happen a lot, is it? Over here we have, you see the number of years span from 1880 to 2011, is it? So we have a lot of files we needed to read and then combine them together, is it? And to have your data frame created. So the way to do this over here, what it does is it use a loop. And with the loop, it specify each individual file. Okay, so for each year, the baby is stored in a single file. And then it does the read CSV as it get a frame, is it? And what next is it's going to call the append, is it? Call the append. And then over here, it's going to concatenate everything together into a single data frame, because that's what we are going to do with that single data frame. Okay, once we get this, and here give us a glimpse of what this data frame is it? There are not a lot of columns, it just has name and the boy or girl, and how many for that year, is it? For that specific name and the year. Okay, so that's the general information. You can see there are quite a number of rows, is it? Over 169 rows, is it? And then what next it shows, we are going to do some analysis, is it? The first one it did it called the pivot table, is it? And the pivot table previously we also discussed. You can do some grouping thing with the pivot table, is it? And here it specify, okay, with regarding the pivot table, the column is going to be on boy or girl, okay? And the index is going to be year, okay? And the because pivot table normally to give you the aggregation information, is it? So over here, we specify the aggregation of our data is going to be the summation, okay? You wanted to find out the boy and the girl born in that specific year, is it? So once we have this data, then we just do the plot, is it? So the plot shows us like this. So it gives us some idea about the boy and the girl distribution, is it? From 1880 to 2011, is it? Okay, so that's what this part does. And what the next part did is define a function called add prop, is it? So over here, what it's trying to do is try to add a new column, okay, in our original data. Okay, that column, what it does is to based on a certain group, is it the number of boys or girls' name, is it, versus the total number of the boys and the girls through all of the years, is it? So that's what it did, the proportion basically, is it? And you define this function, and then we can do also the group by, is it? And over here, this group by, it gives a group by what, by year and the boy and the girl, okay? And then you're going to apply that proportion function. So that will be the aggregation function that you define. And then we will have this new result, is it? So that's about the propagation distribution. And after that, what you try to find out is over here, we try to verify that the propagation column sums to 1, is it? Because that's the percentage, is it? And based on each year, it is supposed to be summation to 1, is it? So then you can do that group by, is it? And pick that propagation column and then call sum, is it? Here it's verified that it is 1 after you add that. And what the next one shows us is we try to get some top 100 names, okay, for boy and girl, and also every year combinations. That how do we do that? So over here you define a function. We call it get top 1000, okay, and then you provide the group, okay, the group information. And then over here, because you're going to get the top 100, so you're going to do some sorting, is it? And sorting, and you specify by what to sort, is it in ascending or descending order, and then you just get the top 100, is it? And what the next one shows, you do the group by, is it? We do the group by year and a boy and a girl, okay? And after that, you're going to get the top 1000, is it? Get top 1000. And then we are going to see what it looks like, is it? So there over here, to give us the top 1000 names, okay? And it's arranged by year and also by boy or girl. Is it? It's over here. If you take a closer look, you will find the over here to first show all girl name, is it? And by year, is it? And then follow that is going to be boys, is it? So that's what our group by over here defines, is it? Okay, so that gives another information, and then we can also over here says analyze the name trending, is it? So with that top 1000 is a boy and a girl, so you can do some filtering work. So this shows how to do the filtering work. And what the next one shows is we do that pivot table again with the top 1000 data this time, okay? And you specify the index and the column, and also over here this time, for the pivot, what we are going to do is going to do the summation, okay, do summation. And after that, what we are trying to do, we just pick some name, like John, Harry, Mary, Marilyn, is it? We pick some common name out of this top 1000 summation result, is it? And then we are going to do some plotting here, okay, the plotting, to find some trend, is it? So over here, it gave us the plotting result about each individual name, is it? Each individual name, how it distributed over these years, is it? So from the trend, it's kind of, you will see it's kind of those 4 names pick between 1920 to 1960, is it? And then it's not that trendy anymore, is it? So that's what the plotting shows us, okay? And what the next part shows us is to try to show how the name diversity works, is it? So over here to use at the top 1000, again, do the pivot, is it? And also specify the index and the column, is it? And based on the value of what? It's based on the proportion, okay? So based on the name proportion column. And do the aggregation on the summation also, is it? And then we do the plotting again, is it? And from this plotting, you will also see, is it? By the propagation, the name is trending. It's a kind of, we see for both boy and girl, it's also kind of decrease, is it? And then next one is to try to show a specific year filled out. Over here it's filled out 2010, okay, the name. And over here it's the data, because later it's going to use that data for some more analysis. So this is our DF, okay, data frame. So only regarding of the boy's name in 2010. And then we are going to do sort, okay, do the sorting, okay, and do the sorting, and we want to find out over here says how many of the popular names reach the top 50%, okay. Try to find that kind of information. And over here to find out there are 116, okay, reach the 50%, okay. So it gives that result. And what next try to show is find the boy name in 1900. Okay, 1900, and then same thing. You're going to find the 50 reach the 50%. Is it how many in that year reach the 50%? Is it? And here it also shows the result. And what the next part is showing us the name. We also use the percentage. Over here it's a 50%, and based on the certain group. So over here we want to try to find for both boy and girl, okay? So we define this function called get quantile count, is it? Quantile count, so you're going to do sort, is it? And then you are going to sort it by what? Is it sorted by the quantile that you define, okay? And then we are going to apply that top 1000 names, is it? And group by year and male and female, is it? And apply that to, we call this function to find the top 50%, is it? And then we can do the plotting. So the plotting also shows us, is it, the popular name trending with the top 50%, is it? Girls looks like a girl's name more diversified. Okay, so that's what this analysis gave us. And then next, let's see. Let me see, how do I get to the next one? It's going to be, okay, so let's take a look at this one. It's also about movie reading, okay, but this one compared with our first case study, it's not that comprehensive, okay. But over here, say similar as what the baby name shows, we also have different files, is it? You see, we have different files. So with each file, we can create the data frame, is it? And then what we are going to do over here, because we want to get them together, is it? So you can do the merge, to merge the data from different files into a single data frame, okay? So that we can do some analysis. So that's what over here we did, try to show, okay, to merge. And after this, similar, we are going to do the pivot table to do the grouping, is it? And over here, we try to pick the index and the column, is it? So column is based on the gender, and the index is on the title, is it? And based the aggregation is to do the mean value, okay? And here it shows the result, is it? And what next try to do is also do group by. So you can see with all of our case studies, the group by used a lot, is it? That's why I said like the group by is a quite useful function, okay, for the data analysis. So over here, you're going to group by the title, is it? And after that, you try to find out the number for each title. So that's what we interested. And then we, based on that, we also try to do some filtering work. Okay, we said, okay, some active titles. So you're going to, based on the rating greater than certain score, that, and you're going to get all of those titles. Okay, so that will give you those information back. And what the next one try to show is, then based on that, you want to know some detailed the rating, is it? And the rating also from male and from female, is it? Then you can apply that active title. You just filter out, is it? See as your selection, and then it gives you the average score, is a rating score for each different movie, is it? And also the distribution between boys and girls, okay? So that's the information. And what the next part shows is, so over here, it's just try to do some renaming based on our mean ratings. Okay, we already do the group by for the mean rating. And what next try to show is try also to, you can then do some sorting, okay, with your data. Is it over here? It's specify, you can also specify by which column, is it, to do the sorting. Over here, I said, okay, I'm trying to do the sorting based on the female viewers, is it, to do the sorting. So you can do something like that. And over here, you can also find the discrepancy, is it, a disagreement between male and female ratings, is it, based on the data. So then over here, you can specify, is it, the specific column. And then what next it try to show is, you can also do sorting, is it, with that data, and then by what you can specify the difference, is it, because over here you add that column, is it, and then do sorting. Okay, so that's regarding that part of group by. And what the last one try to show is, with your analysis, you can also do some statistic data collection, is it? Like over here, you can also do standard deviation collection, is it? And then you can do sorting based on the standard deviation, okay? So that's what this case study shows. And then next, let's take a look. What's the next case study? The next case study is about some food, okay, analysis. So it just shows a different case study, then it will help you when you do your final project, okay. And this time, the file is going to be a JSON file. And previously, we also discussed how to load a JSON file and convert it to data frames. And because it's a JSON file and it involves a key and the value pair, is it, for the JSON. So over here, what is the key part? We first try to do, so if you want to know all of the keys, you can do the dot keys, is it? And then over here, I pick the nutrients key, is it nutrient key? And because it's a JSON file, the JSON to record corresponding to the key, you can then have the value. The value can be some other string or scalar data, or can be some other JSON object. Is it in this case? For this nutrient key, the corresponding value part, you will see it's a JSON object, basically. So it has multiple items. It has ID, description, text, manufacturer, group, portion, nutrients. Is it has quite a lot of, oh no, I'm sorry. The part, what it has is the value, units, description, and the group, okay? So that's regarding the nutrient part, okay? So it is another JSON object, so that's why it has key value again, okay? So regarding that nutrients. So basically over here, maybe a little bit. So the general, it has the key, so those are all of the keys. The key, and the nutrients is one of the key. Is that one of the key? And under this nutrient, it has, so it's multi-level basically here. Under this nutrient, then it has value, is it, and it has units, and the description, and the group. Okay, that's what it means over here. And then they have their corresponding value part. Okay. So it's kind of involve multiple level. And then what we want to do is over here is we are going to focus on the nutrient part of the data, okay, for our analysis. So here it gives us a glimpse of the nutrient part of the data frame, is it? So we create this data frame, and it has value, units, description, and group, okay, and a lot of data. And then we are going to create the data frame, okay, with what we just extracted information, okay. And here it gives a glimpse of the data frame. So all of this part is just shows us how you can build a data frame also from JSON file. And what next try to show is then we do the value count, okay, based on what? Based on the group. Is it on the group column? Then you do the value count, okay? And over here to give you the first 10 value count for each category of the food. And what next part try to show is we are going to try to also add a new column for our data. We call it ID column, okay? ID column. And that ID column is from the original data that we collected. Okay, it's not just from nutrient. The nutrient part we already got it. This is from the ID. We want to add that part also, and then we can do the concatenation that to add to basically expand your data frame. And then over here just shows, because a lot of time you have some duplicate data that you want to drop off them. So that's what that part means. And over here, we have a dictionary, is it? And then we call the rename, is it? And over here is rename again, because some of the column name, you may want to rename them, is it? And when you do your data analysis and report, and how you do that, you can just call rename, is it? And then plug in with a dictionary to give your column name some new name. And then here it shows us our data frame after we rename. And then over here, we also, so over here we have our nutrient data frame, is it? And we also have this new one, we call it info, is it? Data frame. And then we try to do some merge. Previously we discussed merge, is it, in pandas. And when you do merge, you can specify on which column you're going to do the merge, is it? And how you do the merge, is inner or outer or left or right, is it? Those you can specify. So over here, it's going to do outer merge, etc., and based on the ID, okay? And then you will have a expanded data frame, more information. And from that, then what over here we try to do is we try to do some plotting, okay? And the plotting going to be based on nutrient and the group of the food group, etc. And it pick the value and do what? It's going to do the quantile, reach 50% of certain nutrient, etc. So you're going to do that, and then we are going to sort and do the plotting. Okay, so with this, it gives you the food group, is it the distribution, is it? And because over here we already called the group by, okay, so you can get, you see, quite, and you also sorted the result, the visualization. And what next try to show is also do group by, this time it's group by nutrient group and the nutrient, etc. And what next over here, we define a lambda expression. And this lambda expression just get out each item of your data frame. And what next we try to do is we apply that lambda expression, is it, with our group by result, okay? And then we are going to display its value and its food, etc. So over here, it gave us a glimpse of what this result looks like, etc. So yeah, for each food, that each group of the food, and it gives you the nutrient value, that's what that part means. And what next one shows is, then based on that, we can define some other lambda expression. So this lambda expression try to define is to get the maximum value, okay, the maximum. And the ID max method, it's what? It returns the index of the first occurrence of the maximum value, okay? So that's what this method gives you, so that you can retrieve the index of the first occurrence of the maximum. Basically, over here, what we try to do is pick the most nutrient one, is it, from certain category of food, is it? So that's then you can see over here what you can do is you can call the group by, is it? And then you can apply the whatever the aggregation you want to do. And here is to do the maximum, is it? But maximum based on what? Based on the first index, is it? And the result will give you, is it a nutrient group and the nutrients it has, is it? And what the value it has. This is the first largest one, is it, from that food. So it gave us a clear idea about the nutrient distribution. And what is the next one? Because the nutrient the food and the nutrient description, it's a long string, is it? So sometimes maybe you just want to do some slicing. You don't want that very long description. Then over here, you can apply the slicing. So that's what this part shows. Okay, so this is the result about the discussion about the food distribution. And what the next one is to discuss the election, okay, U.S. president election analysis. And over here, it has a CSV file about the election, okay, Federal Election Commission database, okay, and it's for 2012, year 2012. And the basic information we have over here is about the contribution, okay, of your donation, is it? So the donation ID, is it? And this is about candidate, who you are going to donate to as a president candidate. Okay, and this is regarding the donation amount. No, this is regarding donation amount, contribution amount, okay? So this is from who contribute, is it? And the contributor city, state, zip code, employee, occupation, is it? Contribute receipt amount, is it? And receipt description. So a lot of information here, okay? And this is, I believe, candidate, yeah. This is regarding president candidate name, okay? And we can, so that's the general column information. And then over here, we get a glimpse of this data frame. So you have the contributor, is it? And the contributor to who the candidate is it? And then this about contributors information. So in this data frame, you have two set of information. You have the presidential candidates information, is it? And we also have contributors information, okay? Then next, let's see what we are going to use. And here you also can specify specific contributor, the donators information, okay? And then what next one is, from this database, you want to find out all of the candidates, is it? The presidential candidate. So in this case, you can call the unique function on what? On the candidate name, is it? And over here, that's what we find out of the candidates, is it? It's Michelle Bachmann and Mitt Romney, is it? Barack Obama, is it? And I believe there are 13 or 14-ish of candidates, okay, in that year. And in the database, it didn't provide the party belongings, okay, party belongings. So what this part, this dictionary gave us is, but this is public information we can all find out, okay. So over here, we manually provide a dictionary and give each candidate its public, its party association. And then what next we are trying to do is we are also going to get the candidate map, its party, is it? Map is party. So that's how we did. Then you can provide you can call map function, okay, to map the candidate name with its party, is it? And then we want to count, okay, how many from Democratic and how many contributed to Republican, is it? So it gave us a clear idea how many. So this is regarding the number of donations to Democratic Party or Republican Party, okay? And what next shows us is about the donation. So you have more than $0 donation, is it? How many? Is it totally? In this database, it gave us some of them they didn't donate or didn't have the record. Is it? That's what that part means. Oh, what is the next? Just go to some. Okay, we finished that. Okay, and then we come to this cell. So what this cell, then I'm going to filter out, is it? All of the, because I'm only interested in the whoever donated, is it? If there is no donation record, I'm not interested. So then you can do this kind of filter out, is it? And based on that filter out, we are also interested in some more information about, we only interested in those two final candidates, is it? So we only interested Democratic Barack Obama versus Republican Mitt Romney, is it? So then you can keep doing the filtering and record the data in this new variable, okay? And what next part try to show is, it also try to show the donation information by occupation and employee, is it? And then if that, you can do the value count, is it? Okay, so this part shows by the occupation, is it? How many attorney donated, is it? How many physicians donated? How many teachers donated? Those kind of information. It gave us also clear idea. Looks like retired people contribute more, okay? And what is the next one is just try to do some cleaning work. Okay, this is just try to do, because in the original column, those like the CEO and C data, E data O and versus, we want to just record it as CEO, etc. So that's what we try to do, that part. Then do the mapping to do some column cleaning work. Okay, so that's not a major thing. And what is the next one is try to call the pivot table again, etc. So this time we do the total contribution calculation, etc. So the aggregation function is about the summation. And then we try to filter out by what? Filter out by all of the occupation, okay? The contribution greater than 200,000, okay? We want to get a glimpse of those information. And then here we can find out of those information it give us, is it? So of the contribution summation greater than 200,000, is it? And also we also say by occupation, is it? And also based on Democrat and Republic, is it? So the data category is quite clear. And then with that data, is it, we can do some plotting, is it? And then you can see the result quite clear, is it? Use this kind of plotting, and you can clearly see a Democratic versus Republic among all of the different occupations, is it? Different occupation more toward which party, is it? This kind of information, okay? And what is the next one try to show is you try also a lot of time get the top donors, is it? So over here is to try to get a function called get the top donors. You can specify top 10 donors, top 5 donors. Is there something like that? Okay, and over here you try to group by what? A group by the different candidate, is it? So we are trying to compare the donation between Mitt Romney and Barack Obama, is it? And then over here, then once you define that function, is it? Then you can try to based on occupation and based on employee, is it? And pick top 10, top 7, is it? You can get that kind of data quite clear, is it? And you can also do plotting, is it? So that's what this part show. And what the next part try to also show is the donation bucket, is it? Okay, it's between $0 to $1, is it less than $1, or between $1 to $10 or $10 to $100, is it? You want to, we want to get those kind of information, is it? So then in that case, and in that case, we can call this cut function. As a previous unit, we also discussed this, quite useful, is it? So you can do the bin count kind of, is it? And after that, then over here, what we show is you just do the group by, is it? And then you can use the different category, is it? And with the category, you can also see the number. So which bucket contribute more, is it, toward which candidate? It give us some clear idea, is it? And over here, we can also plot those kind of information, is it? So between those two candidates and among different buckets of the donation amount, is it? And give us this plotting. So you can see, from which bucket the candidate get more donation, is it? And over here, it also shows us the donation study by state, is it? Between those two different candidates, is it? So then in this case, when you do group by, you can do group by what? By state, is it? And also the candidate, is it? You can do the group. And then over here, we interested in the count total amount greater than 100,000, is it? And then it will give you this data filter out of the big donation states, etc. And you can also compare between those two candidates. Is it so quite useful? Is it? And what this remaining, the last theory discussed is just you convert the percentage. You can also compare the percentage for the state distribution between those two candidates. Okay, so basically those are the of the case studies that we discussed. And so basically we finish all